I first want to give a big thank you to all of our Capstone sponsors. The difference between having Capstone sponsors and not is the difference between going over the practical as opposed to theory. So we really appreciate your guys' support, especially this semester, especially with everything that's going on. I know times have been hard, and I just want to say thank you. And hello, my name is Brandon Withers. I'm the network engineer and security engineer.
My name is Jeffrey Hughes. I'm the team lead and Ansible engineer.
I'm Christina Raymond. I was the software engineer and one of the Ansible engineers.
And I'm Logan Wilson. I was the hardware engineer as well as an audio specialist.
And I also want to give a special thank you to all of our target sponsors. I know times have been unique and you've still been able to meet with us every week. We really appreciate that, and we appreciate you mentoring us throughout this entire project, being able to work with us, especially with the changing situation. And I would also like to give a special thank you to our professor, Holly, not just for this semester, but for all the years now that you've provided us guidance and helped us through this program and have been mentoring us on how to be professionals in IT. Thank you, Holly.
We want to highlight some of the great things that Target has been doing for our CNIT program here at Stout, besides their involvement with our Capstone. Target has been coming to campus for meet and greets to give us ideas on what to expect in industry. They have also invited us on tours of their Brooklyn Park campus. They have worked extensively with our new Women in Information Technology and Security organization, or WITS, and they set our WITS members up with mentors within Target. And personally, I was given the opportunity to have an internship with Target last summer with their wireless connectivity team. And I was included as a team member and jumped right into working and learning. They have been an active partner to our program and care about our success, and we cannot say thank you enough.
All right, so just a few facts about Target. They have over 1,800 stores, 41 distribution centers in the US, and their corporate headquarters is in Minneapolis. They also have 5 additional offices across the country and a global capability center in Bangalore, India. And that totals more than a dozen sourcing offices globally.
And now for our agenda, first we're going to go over the problem statement. Then we're going to go into different aspects of our design, from our network to security to SNMP, and then finally Ansible. Then we'll give you a few short demonstration videos, go over the lessons that we've learned over the course of this project, and answer any questions that you may have. And if you could please save your questions for the end, it'd be greatly appreciated. Thank you. So Target asked us to redesign their WAN infrastructure.
They also wanted us to provide a quick way to look at network health statistics.
And they wanted us to do this with the network as code mindset.
So these are just an overview of the deliverables we provided to Target. We started off with a high-level design, kind of an overview of what our goal was for the project, what their specifics were. And then we went to more low-level design, which was very in-depth and very detailed proposal for them. And then here we are at our presentation today.
So why would Target want to change their WAN? Well, first off, they want to expand their capabilities and their speed. They want to support new networking technologies and want to stay up to date. They also want to have a simplified infrastructure for troubleshooting, and this can also come into having better cost savings by changing their infrastructure. And they also want to future-proof their network. So if they did want to add even more speed or more capabilities, they can with a fairly modular setup.
Then getting into some of the benefits of why you should have network monitoring on your network. It's going to monitor any devices that are either slowing or failing. And the reason you want to monitor for these is any failing devices can pose a serious threat to your network and also your assets. For network monitoring, you can create custom alerts that can email you directly whenever an alert occurs. You can also create some custom reports to view availability and uptime for specific devices or for the entire network.
So what is network as code? Its network requirements are embedded with application code in a source of control such as GitHub repository. And then the network requirements are held in data formats that can be processed by a deployment tool to the network. So what does all that mean? So let's say a new store is ready to go live. Code is written for the devices in a language that can communicate with network devices. The information is stored with all the necessary applications and libraries in a repository such as GitHub, as I said. And when changes are needed, a launching platform like Docker is used to push out the specific code to the remote devices on the network from a single point. And this limits the number of hands touching the equipment and limits the chance for unwanted behavior and configuration drift, while keeping the network safe and keeping track of changes so the company can put more resources into taking care of their customers.
So Target was kind enough to give us 6 routers and a server for our project. Unfortunately, they gave us the last pieces of the equipment a day before the school went into lockdown. So we spent spring break trying to come up with alternative solutions to still meet the requirements for the project. Well, luckily, I have a server at home, and I reworked it, installed GNS3 and VirtualBox on it so we could have a virtual implementation. So here's a couple pictures of my home lab. I took the iOS from one of my routers and put that in GNS3, and this is actually my setup right now. So we've been able to virtualize our entire test topology and install all of these capabilities onto it. So this basically represents Target's current network. So they had 4 routers at the distribution, and then they go to some core switches. And so what we've done is the all-PE here for our test physical topology, it looks fairly simple. The all-PE basically represents the perimeter edge routers that is the provider. And then we've consolidated those 4 other routers into a singular one. That way we can simplify the configuration physically. Logically speaking, though, it's fairly complex because we're using VRF. And what VRF does is it creates virtual routers inside of your router. So we have 4 separate virtual routers on the all-PE representing different parts of Target's network from store, cloud, headquarters, and international. And what this can allow us to do is even distro has 2 VRFs, one for general traffic and one for international. We can force that international VRF to go through our firewall without adding any more connections and maintaining a physically simpler network. And this is how we set up our routing, and it's fairly standard. We're using Cisco proprietary EIGRP for our internal network, and we're using eBGP for the external with redistribution going on at the distro router. And for our firewall, we decided to use pfSense, which is open source, user-friendly. It has a large community support, and it is extremely lightweight. For our current setup, we're using 1 core and 1 gig of RAM. Granted, we're not pushing that much traffic through, but its performance has been astounding. And this is how we set up our firewall. The all-PE international traffic goes to our distro's international traffic, which pushes it through our pfSense, which blocks telnet, and then it hits the general VRF, which can hit all other parts of our internal network.
Yeah, so for our network monitoring solution, we chose to go with Nagios. Like pfSense, it's also an open source solution. It allows for SNMP monitoring from your routers as well as SSH monitoring from, say, your servers, which is how we set it up with our pfSense servers. It's a relatively simple design. Once you get one device configured, you can kind of copy the code over and change a few variables inside of it to monitor different devices. And it also has plenty of extended features as well as documentation that you can download from other repositories that members of the community have created. This is what you'll see inside of Nagios. This is our host groups page. Kind of just gives a quick overview of all of the devices you're choosing to monitor. You can organize it however you like. And you can click on each device and get a more in-depth view of certain things that you chose to monitor. And you can get a lot of in-depth statistics for the overall health of your network.
So for our network as code implementation, the theory was that we wanted to use an open source infrastructure automation tool. So we ended up going with Ansible, which allows for that configuration with the network as code concept. One of the things that's nice about it is it decreases device configuration times because you predefine your playbooks that have your device configuration defined inside them. And by doing this, you use those playbooks to enforce your configuration requirements. And so you know that your devices are configured with those because you periodically make sure that they're configured correctly. But doing this, it makes it so that you can eliminate configuration drift. And by eliminating that configuration drift, you can reduce the troubleshooting surface when there is an issue because you know the devices are configured the way you want them to be. One of the things that's very nice about Ansible is it has a large community of support, and it's compatible with many of the major Linux distributions.
So as Jeff said, Ansible works with many different operating systems, and for our Ansible server, we use the Linux distribution of Ubuntu. Ansible uses playbooks that are written in the human readable language of YAML, and that is used for data serialization and transfers. And then the playbooks, such as the one shown here on the right that we wrote, tell the network device to perform some task. And this one in particular is to turn a particular interface on. This playbook is issued from the Ubuntu command line with the command showing in the very top image. And then in the bottom image, you can see what a successful completion looks like. And in industry, the playbooks would be held in a repository like GitHub, like we mentioned earlier. And then the changes would be deployed from a platform like Docker. And for our virtual network and for time saving, we kept it simple and just use our Ansible server. And now we will move on to the demos.
Brandon, you're muted.
This is our GNS3 setup. These are our 5 routers, 2 firewalls, and then 2 servers. And now our demonstration next.
At Nagios now, this is our Ubuntu server connected to our MLS1 router. Here we have our host page that you see when you first come inside of Nagios. Here we have all of our hosts that are configured to be monitored, our routers, as well as our firewalls. And if you want a more in-depth look, you can organize things to however you see fit. All these naming conventions can be changed to whatever you like. This is just how I felt best to organize them. And if we go inside, say this distro 1 router, we can see ports that are being monitored and their status is okay, as well as their duration, how long they've been up for, how many attempts it's taken. So if one attempt fails and it goes to a second attempt, that status might change to a warning saying that there might be some sort of failure occurring. And if it goes to 3 of 3 and fully fails, it'll go to a red critical warning. And then all those things can be configured to send certain alerts, and we can even look at things such as a report So last 7 days, recent alerts, as well as availability. So if we just want to do all host groups, and then you can pick whichever one you want. We're just going to do all host groups here as well. We'll do it for the last 7 days. Create availability report. And you can see our uptime for every single device during that time. And you can see that these firewall servers have been down, and we'll cover as to why that is later on. And that's it for Nagios.
This is a demonstration of using Ansible to configure MLS2 to open an interface. If we look at MLS2, we can see that interface fast Ethernet 00 is down currently. We're going to use an Ansible playbook run to open that interface. This is the playbook, and when we run it, it's going to connect to MLS2 using Telnet and open that interface by sending the no-shut command, as you can see here. And now if we look at MLS2, we can see that fast Ethernet 00 is now up. That concludes this demonstration.
This is our Ansible server right here. And over here is the MLS2 device that we're going to be making our changes to. So let's go into our server. And right here is the Ansible playbook that we're going to be running. We're going to create a directory and use Telnet to get into the device because we are not able to SSH with our current setup due to limitations. And then we're going to run the show configuration command. We're going to save that into this variable output. And then back in our server, we're telling it what to do. And we're going to create a backup config file into the backup directory with the variable that we are creating. So let's go in and run that. And if I run the ls command right now, I can see that we do not have that directory at this moment. So we'll run the playbook to run that command. So we're running the playbook, telnetting into the device, making the directory, getting the configs from the router and saving them into the variable, and communicating back to the server, and then writing all that information to the directory file. And it looks like it completed, so let's go take a look at that. Yep, the backup directory is there, so let's go into it and run it. We can see that the backup config file is there, so let's take a look at that. And it is there, but it's in a format that's a little difficult to read. So I'm going to run a sed command to show it. And normally in a production environment, you would use Ansible to do this without having to run this command. But for time constraints, we are going to do it this way. And there it is. And this demonstrates the power of Ansible and how important it is to push everything out from a single point so that you can pull all your information and pull it and push it out all from a single source. Thank you.
So here we can see our total hours worked. We spent over 400 hours on the project. Initially, we created a proposal to meet Target's needs. They approved and provided us with the equipment necessary to accomplish the project. Unfortunately, school closed during spring break due to COVID-19, which affected the hours that we were able to work. Luckily, though, Brandon was able to utilize his personal equipment to support a virtualized variant of our initial proposal. Target approved of our adaptation. We were able to get back to work and finish. So you can just see here that you see that little slowdown in the middle was when we had the spring break and the COVID-19 issues. And once we were able to resolve our conflicts and get that alternate option up and running, we were able to get back to work right away.
So for lessons learned, the first thing I've learned over the course of this project is we are completely spoiled at UW-Stout with the equipment that we have. It's all pretty cutting edge. So a lot of the problems that we came with our newer implementation were because I was using my personal older stuff. Even the equipment Target gave us was really good cutting edge stuff, which we unfortunately didn't get much of a chance to play with. And for instance, because I'm using an older iOS from a router, we can't use SSH and VRF, which you can use in a later version of that iOS. So we've had to come up with some unique solutions like using Telnet instead of SSH, which actually caused quite a few issues in the project. So I've learned that we are very spoiled. I also learned that pfSense is extremely lightweight. I was very surprised what little resources it took up, even for this test implementation. So I thought that was extremely awesome. And then I also learned that the virtual connections between GNS3 and VirtualBox, especially the latest versions, can be somewhat unstable at times. Like Logan showed earlier during his demo, with downtime with those pfSense servers, it has nothing to do with like the actual like network itself or the configuration. It just has to do with that virtualized connection between GNS3 and VirtualBox. And the last thing I learned is my group members are awesome. Even with COVID-19 hitting, we were able to meet back up and come up with a new solution and be able to push this project through and hit all the targets we needed to. I'm very grateful for the people that I got to work with, and this was a great learning opportunity.
Yeah, for me, I think communication was just the main thing I took away from this project. Being able to know who's doing what and being able to stay on track was very important for us. And there were lots of times where we were communicating late at night with trying to get everything done in the short amount of time we had after having to make this big change. But aside from the communication aspect inside of our project, before we were selected to go with Nagios, we were looking at Isinga, which is another network monitoring solution. And we were able to get it installed on our server, but we were running into some issues inside of CentOS 7 as well as Ubuntu. CentOS 7, we were having issues where we weren't able to get the packages we required. We were able to get to the web interface and everything just fine, but those packages weren't able to be installed. And then inside of Ubuntu, we were getting some PHP errors that was preventing us from using it there as well. So I think it's just good to have a backup plan for anything you plan to do, because more often than not, there's going to be some issues along the way and things might not go as planned.
For me, there was a few lessons that I learned while I was the team lead and responsible for making sure that everything gets done. It benefited me greatly that each member of the team took their own initiative. They were proactive and they set and met their own goals. They also communicated well and accomplished tasks in a timely manner, especially when other members needed them done so that they could do the things they needed to do. We spent many hours collaborating over video chat and screen sharing since we couldn't meet in person. We shared the research with each other that we did, and we built on each other's ideas. And I think that everyone adapted well to the changes both in school and out of school.
What I learned was how important it is to remain flexible and to communicate, and how grateful I am to our instructors for teaching us how to research. As was mentioned before, because of the suddenness of no longer being able to work with the equipment that Target gave us due to the virus, we had to be flexible in figuring out solutions, and we had to communicate with our sponsors and each other on the best way to pursue the project. We had to act quickly and learn extra things we weren't expecting, like how to get all of our virtual environment working with the resources we had. GNS3 prefers to use VMware, but we were limited to using VirtualBox because we didn't have time to try to get the licensing for all the extra devices for VMware. And we were able to work with that and spent a lot of time researching, getting all that put together. And so thankfully, we have been prepared by our instructors to problem solve and research. And I am extremely grateful for my team, and I am extremely grateful for my instructors for teaching us and going above and beyond. So thank you.
Now, are there any questions?
Hey guys, this is Lucas from Target. I guess I had two different questions. One being, I know that some of your time had been maybe consumed by the COVID-19 switch. If that hadn't happened, is there anything on the project that you might have wanted to expand on?
We would have used SSH instead of Telnet for sure.
Yeah, definitely. We were limited in our ability to utilize the full capabilities of Ansible because of the fact that it's designed and relies around being able to communicate over SSH to use the modules that are inside of it, which would have made it a lot, definitely more complicated initially, but it would have made it easier for us to fully utilize its capabilities.
Yeah, I think with Ansible too, I would have liked to have been able to work with that. That backup config file, I would have liked to explore further, taking that file and pushing it back out onto another device. Yeah, the limitations we had kind of prevented us from really exploring that too much with Telnet because of the VRF and VRF aspect we had to continue to use. So I think that's something I would have preferred to try to explore further.
In the iOS, we were using kind of limited some of the things we could do with our routing. So it's not quite as neat and professional as I would have liked it to be. But for the constraints we had, we were able to pull it off.
Awesome. Well, good job on the project. I just had one more question. Can each of you hit on what was your favorite part or something that you think that you'd be able to bring in, something you'd want to work on later in life?
I think emergency preparedness is a kind of a big thing. I think I would like to work on, like, how can a company prepare for something like this, especially technically, and then coming up with solutions for, disaster recovery in a disaster that isn't exactly technical related.
Yeah, I think for me, the best part was just looking at all these separate aspects and how they all combine together to, form the project as a whole. There's a lot of pieces that come together to make this thing work. And I think there was just a lot that we really couldn't do, even though we did a lot with our situation. There was just a lot more we could have explored. But overall, there was a lot to take away from this entire project. Network automation thing is super important and a super up and coming thing that I think is a very valuable thing to learn about.
I think for me, what I really wanted to focus on maybe in the future is working with the virtual environments, having to research into what was going on with between GNS3 and VirtualBox, and getting the PF Sense and all the virtual machines up and running. that was really, really interesting. That was probably my most time-consuming part of this project, other than Ansible, of course, trying to get that to work with Telnet. But I think I want to look into more on the virtual aspect of setting up the networks.
We spent a lot of late nights on that, Christina.
Yes, we did. Lots of late nights.
I think for me, the thing that I enjoyed the most about the project was not only working with the team, but using our collective backgrounds and educations and exploring the new concepts that we had to implement. I personally never worked with anything that had a network as code concept besides using just like a simple backup server for configurations and things like that. And so it was very interesting to me. I think in the future it would be really cool if I could work somewhere where I got to explore the full functionality and capabilities of some of the tools that we used in this project. But I definitely had a great time learning the new stuff.
Hey, this is just Josh from Target. Hey, one quick question. What led you guys to do pre-recording for all the demos, even including the audio portion of it?
We experienced some technical difficulties trying to do them live when we were practicing, and we decided that it might be a good idea to have recordings so that way, in case there's any issues, we were able to resolve them, or we could negate them as an issue.
Yeah, one of the things that we had was only one of us can be in the server at a time with the way that we remote in. And so we would have to pass control to and from. And we find that was kind of time consuming.
Yeah, that makes sense. I figured there was some kind of limitation like that. Appreciate it. Great job.
Thank you.
Thanks.